Well, good morning, everyone. I'm Paul Wilson from APNIC. I'm very sorry not to be able to join you in Beijing for the GNTC this year. So I'm talking to you from APNIC headquarters in Brisbane, and I'd like to thank BII very much, and also my friend Liu Dong and his staff for making it possible for me to be with you here at this important event. It's my honour to be here to speak for APNIC, for the Asia Pacific Network Information Centre, and I'm going to talk about IPv6 deployment around the world. I think we all know that IPv6 is the future of the internet. We will all be relying on IPv6 sooner or later, and we all at some point need to do some work to get ourselves ready for IPv6 and start participating in the IPv6 internet. So APNIC for quite some years has been both promoting IPv6 and also measuring IPv6 on the internet. And I'm going to talk this morning about some of the initiatives from APNIC and some of our partners in measuring how IPv6 deployment is going. And I hope this is of interest to you at the GNTC. I think we all know for a start that the reason for IPv6 is the limited address space of the IPv4 internet. IPv4 address space is running out quite rapidly now. As you probably know, there are only something like 20 million IPv4 addresses still remaining out of 4 billion IPv4 addresses potentially. In the APNIC region, we still have small rationed allocations of IPv4 available to those who need it, but that supply is only going to last for another 2 or 3 years, and it's certainly not enough for any significant IPv6 network deployments, or it's certainly not enough for any significant network deployments, because these now have to be done on IPv6 and not IPv4. So what we want to do is to be able to track IPv6 capability as it develops around the world. What this chart shows is the growth of IPv6 capability around the world, which has increased from around 6.5% this time last year to well over 15% at the moment. And that, I think you'll understand and agree, is a very substantial and promising growth rate for the end user capability of IPv6 deployment. We can also look at the amount of usage of IPv6 from different perspectives. So at Google, the number of IPv6 users that they measure has increased in the same period of time from 12% to 21%. IPv6 traffic volumes are being measured as well, and these figures come from the World IPv6 Launch Organization, which shows the largest ISPs in terms of IPv6 traffic volumes. The interesting thing about this chart is that 3 of these top 10 ISPs actually operate in the Asia-Pacific region. So we have KDDI from Japan, we have Reliance from India, and we have SoftBank also from Japan. The reachability of IPv6 websites is something that, interestingly, is sitting at around 25% fairly solidly in terms of the number of websites which are reachable. What Google has shown, though, is that, for instance, in their case, the amount of IPv6 volume that is being delivered by Google is continuing to increase, even if at the moment the number of websites themselves is fairly static. I would suggest that you could expect this number of websites that are being accessible at the moment via IPv6 to increase steadily in future as more and more users become IPv6 connected. As a final set of statistics from the IPv6 labs at Cisco, there is a global analysis of IPv6 routing, of IPv6 end user capability, of content and overall deployment. In the case of mainland China, we have, as we see here, 13% of IPv6 address space, 13% of prefixes are IPv6. 39% of autonomous system numbers in China are IPv6 capable, 19% of content. And at the moment, just 1% of users, but I understand that is going to be changing quite rapidly in the coming year. Now, if we look at individual capability of ISPs and countries in the world, the chart here shows the top 10 countries in particular. Now, at the top of that list is Belgium, with 59% of its users being IPv6 capable. But as we go down the list, we see several economies from the Asia-Pacific region. India, in particular, is now at 51%. Over 50% of users in India are now IPv6 capable, and that is something that has eventuated very recently in the last year or so, and I'll talk about it a little bit more later. The other economies of the Asia-Pacific region which are in this list include Japan, Malaysia, and quite recently Australia, which has joined the top 20. I'd like to look at just a few of the countries and the ISPs that are contributing to the IPv6 capability in our region. In India, for instance, what we've seen is that the Indian capability for IPv6 has moved up to around about 30+%. Now, that is almost entirely because of a single ISP, that's Reliance Jio, the Jio service of Reliance, which has increased very dramatically, as you see in this chart, to now nearly 90% capability for that entire network, and that has increased to that level from very low levels, as you see on the chart here, just a few years ago. Now, there are quite a number of ISPs in India. Obviously, Reliance Jio is the one that at the moment is driving IPv6 capability as it's measured on average across the country. We see a similar situation in Vietnam with an ISP called FPT. Now, this, unlike Reliance Jio, which is an LTE service provider, FPT is a home residential cable provider. They have reached up above 30% of capability, which has brought Vietnam's average total capability to around about 10% in total. Another very recent arrival on the scene actually is the South American country of Uruguay. Now, their major ISP, the major telco and ISP of Uruguay, has recently deployed IPv6, and it has reached very rapidly upwards of about 30% IPv6 deployment. Now, because ANT is the predominant telco and ISP in Uruguay, it has effectively taken the entire Uruguayan average IPv6 deployment up to also the same level of over 30%. And that, as you see here, has happened very rapidly within the last 6 months, actually. So it does show you how quickly IPv6 capability can develop as soon as significant large ISPs deploy the technology. Now, the USA has got a very substantial IPv6 population. It's now been overtaken by India, and India courtesy of the Reliance Jio service. But what this figure shows you is that in the USA, actually, there are at least 20 ISPs of significant size that have now deployed a large amount of IPv6. In this top 20 list, or top 25 list, actually, there are around 10 which have achieved more than 50% IPv6 deployment on an individual ISP basis. In China, as I mentioned before, the end user capability of China is still very low. However, at the same time, what we see are that ISPs in China, transit ISPs, are deploying IPv6, and it seems that they are ready at some point, we hope in the near future, to be deploying IPv6. We've got more than 20% of IPv6 address space in China currently visible in the IPv6 routing tables, and that's a good sign. It's a large amount of address space that, as I say, is a good preparation for deployment of IPv6 to the end user at some point, as soon as Chinese ISPs are ready to do that. So all of these figures are intended to show you a positive picture of the fact that IPv6 deployment is progressing steadily, in some cases very rapidly, in different economies around the world. Now, it is a little bit hard to predict how IPv6 deployment will proceed in future. As I've illustrated, some of the developments that we've seen have been very rapid and sort of unexpected, actually, unless we have an insight into the actual planning of the individual service providers concerned. So it is hard to predict the future, but what we can do is have a look at other technology adoption patterns which have happened historically. And for this purpose, I show you the so-called sigmoid curve. Now, this is a theoretical curve which shows the adoption of technology from a starting point of 0% up to 100%. And the figure here shows that in different ways for different technologies over time, something of a similar curve has been followed, whether it's the deployment of electricity, air conditioning, microwaves, or the internet itself. And if we take some of the earlier figures from APNIC, which I've illustrated, and fit that data that we have to the sigmoid curve, then we can actually find an early but quite accurate fit for the data that we have for IPv6 capability against the curve. So as we are reaching something like 15% at the moment, we can see by matching that against the sigmoid curve that in about 5 years' time, we should reach 80% of IPv6 capability around the world, but probably still take up to the late 2020s before we see something nearing 100%. So that's a theoretical curve fit that I think gives a fairly interesting picture that we should have now very rapid IPv6 deployment for a period of the next 4 or 5 years, followed by a completion of that process within another decade after that. So the question is, well, IPv6 has been around for quite a few years, as I think most of us are well aware. So far, many people have not deployed IPv6. Right now, people are starting to deploy IPv6. Industry, ISPs, manufacturers are starting to prioritize compliance with IPv6 and deployment of IPv6. The question for any of us is, why would we deploy IPv6 now? Well, for ISPs, who are the primary users of IPv6 address space, of course, the entire IPv6 world relies on ISPs. And ISPs can deploy now. They can receive advantages by deploying, in particular by offloading the traffic that is currently being routed through IPv4 carrier-grade network address translation devices. Now, those devices, of course, are expensive, complex devices that need to do a great deal of work in supporting network address translation for large user populations. They're a significant capital expense, and by removing dependency on CGNs, that capital expense, of course, can be avoided, and ISP resources can be directed elsewhere to network development and deployment. The other factor here is that if working in a regime where metadata retention is required, then the carrier-grade NAT solution involves a storage of around 1 gigabyte of data per user per month to satisfy data retention requirements. Now, that on a large user population is a very large amount of data. It's a large amount of data to manage and to need to store potentially for several years. And that, of course, also is to be avoided and can be avoided with the deployment of IPv6. The other very important advantage for ISPs, and therefore for the entire internet, is the improved performance that can be received at the user level, at the end user level, by deploying IPv6, particularly in these days where we have wireless networks, whether they are Wi-Fi networks or LTE mobile networks. If IPv4, is being used in the last mile, then it will always involve a second level of network address translation in order to serve something like a home or a small office. With IPv6, that extra level of network address translation is avoided. In fact, all network address translation is avoided, and that provides greater performance and greater efficiency in internet connections. Again, for the ISP, the data center or infrastructure operator, The other important point of IPv6 is simpler network management by using the single IPv6 stack eventually, rather than IPv4 with IPv6 carrier grade NAT, etc. And the other final thing is that all doubts about the deployability and applicability of IPv6 really have now been dispelled. There should be no longer any doubt as to the usability of IPv6, because as you see, it is being used very extensively around the world. So in no sense is IPv6 these days an experimental technology, or one that should come with any particular doubts about security or stability in deployment. So the message that I'd really like to emphasize this morning to bring to you is that if you are deploying internet services in any way, if you are dependent on the internet in any way, then the time for IPv6 can be, and really should be, now. IPv6 in many economies is what we'd call the new normal in internet deployment. In the Asia-Pacific region, we have India, Vietnam, Japan, Australia, Singapore, and New Zealand, which we can now consider to be dual stack economies. That is, they have an internet that deploys both IPv4 and IPv6. And the immediate benefits of deploying IPv6 can be seen at the level of internet service providers, infrastructure providers, end users, and I think the national economy in general as a result of IPv6 deployment. Now, within 5 years, 75 or 80% of all users on the internet will be, by our projections, IPv6 capable. That gives you a window within which to plan deployment. But I think, although it's strange to say, after perhaps 10 years of talking about IPv6, I would suggest that there's an opportunity now for early deployers of IPv6, for early starters to come in and establish a benefit, and again, competitively speaking, from establishing IPv6 services right now, rather than waiting until perhaps the internet becomes more dominated by established IPv6 players. So that's been my message for this presentation, that IPv6 use in the world is growing. It's growing rapidly. It's being used very successfully in many, many parts of the world. The time for IPv6 is now, and I would really strongly encourage those of you in the GNTC audience who are in a position to move on IPv6 to think about that, to get your plans underway. APNIC is here to support that transition in any way we can within the mainland China and the rest of the Asia-Pacific region, and I do hope that we can provide further support to China in future. Thank you very much for your attention. It's been a pleasure being here, and I hope to join you again in GNTC next year. Thank you.